Well, we're at the point where we're going to grind a 15-degree angle on the end of the carbide, and for that I needed to pick this up at my full-time job. I had to use it over there, so I brought it over there, so I had to go back and pick that up, and had to wait till they opened up from the holiday break here. And so anyhow, this is a device that I built, oh, I bet that was 35 years or more ago. It's a 10-inch between the rolls on the centers. I got different units I can attach on here. I can actually make this into a vise, sign plate. I was going to actually make it so that I can turn between centers, have a little motorized fixture, turn between centers, go an angle. I never finished it out that far. But anyway, this thing has come in very handy over the years. And one of the things that I did is when I built this, I put all the 5 degrees, 5, 10, 15, 20, 25, and so forth, and I stamped in there what the gauge block stacks would be for that. And so in this case we need 15 degrees, so I need this 2 inches, 588 and 2/10. And so I made my gauge block stack, and I got that, and so all I have to do then is take and pop that in there. And now we're setting up at a nice 15-degree angle is what we're going to need. And what I can do is I can mount my spin fixture back in here, and in order to do that I got some holes that are tapped all the way through the plate, and so I can take this setup right here. There's a slot that's running up and down that and so I got this where I can slide it up and line it up with some of the holes that are going all the way through on the spin fixture and hold that in place. So it actually works pretty nice combination tool to have over here. And so we'll get set up on the surface grinder, and then we'll come back and show you what's going on. I'm going to break the edge with a diamond tool right here because that's dead sharp, and I'm assuming when Robin, when he bored this, that there was probably just a little bit of a radius on the end of that tool, and that can interfere with the fit a little bit. So I'm just going to grind a little bit of chamfer on there to compensate for the radius. There, just a little bit of a radius on there. Okay, what I'm going to do, you just take this marker and clean up that face and this edge a little bit where I put the radius, coming out a little bit on the taper. And then I'm going to just take this right here, put it down, hold it still while it spins. Take it out, and I can see on the angle where it's hitting, but it's not, let's see, is this a good place right here? I don't see any of the blue transfer from there. and then when I look on the end I don't see any there. So what I'm going to do, I know I'm really close. I'm just going to go down a tenth per side here. Yeah, I didn't realize that I bumped my handle and moved things, and so I had to retouch. And it's real critical that you get lined up right on center, because if you're off, you know, an inch this way and grind that angle, it's not going to be 15 degree. And when I had the bluing on the end, it was about a tenth out. And I could feel just a little bit of rock. Now I took that, actually that ink off, and now it feels real good. It's right there. Okay, so now we'll move on over. We'll get the parts cleaned up and we'll do some silver solder. Okay, what we got going over here, we have one of the tips that Robin sent where he did the angle. He realized that my lathe wasn't a very accurate one, and so he was kind enough to send me 3 of these parts. And what we're going to do is we're going to pop this 1/16 hole in right now, and this is kind of a weep hole for the silver solder, or if I have to add more silver solder, I can use that hole. When we silver solder this, we'll flux both sides up, and we'll have the silver solder in the top. And I just got through talking with Robin on the phone, and he gave me a few pointers on the silver solder, but we'll be heating the carbide mainly up, because this material is like a preheat treated H13, and I thought he said it was in 40 something Rockwell, if I remember right. And so anyhow, what we want to do is try to keep a lot of the heat in the carbide and in this area without messing with the temper over here, and that's one of the reasons why he sent that Stay Silver 56, because it's got a lower melting temperature, and it works really good for projects like this. So anyhow, I already have everything set up here in the vise. I edge found, got my center, edge found, moved over the distance, and I've never worked in this material before, so I'm not sure how it's going to cut, but we'll find out together. Oh, that doesn't look too bad right there. What I'm using a number 2 center drill, because on the very tip right here, that's about a 78 thousandths diameter. And so what I did, I just put just a start hole in there. So the 16th inch drill is going to start with, in other words, it's not, that 16th inch drill is not going to have to be cutting on the crown. If you ever try cutting on a crown, a lot of time it's a little bit difficult. So now we have a good surface for that drill. Yeah, that actually cuts real nice. Now with these small drills, a lot of people tend to run the RPMs too slow, and they pull down with their handle real hard, and so what they have is a slow RPM and a high thrust, and that's usually when you end up breaking the drills. And if they don't break, a lot of times your holes are drilled kind of crooked, because you're just plowing the drill in, and it's going to follow the path of least resistance, and you won't get a straight hole. So I'd much rather drill with bigger drills. They're easier to control. Small drills, just remember light pressure and higher RPMs. So we have the hole in, and what was real nice, Robin had all the dimensions all worked out. Then I want to just show you how close his lathe work is. We just want to zero this out. Now this indicator measures at a 50 thousandths resolution, or 50 millionth resolution. And if we can get Cat to pan back to this print, let's see, we can, let me find it real quick here. Yeah, from right here. The dimension that he has from here to there is 1/4 inch. So, we'll take this. Are you ready over here, Kat?
Mm-hmm.
Again, this indicator has a 50 millionth resolution. He done this on the lathe. He hit that right on the money. He does awesome work. We're going to take this kind of a rough diamond file, and what we're going to do is we're going to scuff this angle just a little bit up, and that'll help the silver solder have a lot better gripping. So we don't want to take anything off there. We just want to get it scuffed up a little bit. Get a little bit rougher surface. And that's got a beautiful fit on there. Well, now we're at the stage of where we're going to solder these two pieces together. And I've been asked about this material for the head that Robin provided. And that is Viscount 44. And Robin said that is a pre-heat treated, or it's already heat treated at about 44 Rockwell H13. I think it has some additives to make it machine easy. I know when I drilled that little 16th inch hole, it actually drilled real nice. I've never worked in the material before, but it's kind of neat. It's I believe a hot work steel. Robin was kind enough also to send me this Harris Stay Seal 56. It's and then a little packet of the black high temp flux that they make as well. And what I was using prior to that was this Stay Seal, and it was a white paste. And I believe Robin said this black has a higher temperature range. And then I was using this Silverloy 450, and the reason I bought this was it's what our local supplier had, but anyhow, what Robin sent is a lot better for the project here. And what I did is before, I had never used this product before. I wanted to test it out, and so I have a lot of little pieces of carbide. I got a lot of carbide inserts, and so a lot of times what I'll do is I'll make up small one-piece boring bars, and I thought, well, this would be a good opportunity for me at least to get one started, because I don't have one in the 5/16 range. And so I wanted to see how this would flow. And are we zoomed up on this, Cat, where you can so anyhow, I just wanted to see the joints and how messy it would be or might not be. Now, this stuff actually worked really good. I really liked it. I liked how it flowed. I liked how it moved. And if I can do half as good of a job on this bar for Keith Rucker as what happened here, I'll be happy with it. I'll grind this up later, put a little point. It'll be a single point boring bar for special jobs. And so anyways, I needed to make me a little fixture because I'm going to have a torch in one hand, and when you're trying to solder these things together, they can move around on you a little bit. So I wanted something that would line it up real nice. And I didn't build this fixture just for Keith's bar, if anybody's asking. I make carbide bars as well. I'm reluctant to sell them because the heads come off, you know, and then people, they want to have a replacement. But the carbide on bars like this alone is extremely expensive. All the extra work, you got to put all the work that you do in a head, and then you got to pocket it. You got to grind the carbide to match. Then you got to solder that all together. But a lot of times I make these bars for myself. This is one of my homemade bars right here. and it's got a different kind of locking head. And the boring bars that we're making now out of steel, they got the screw-in inserts on there. And we have a number of these where one pocket on one side is messed up, but it's perfectly good on the other side. I'll take this over to the cutoff wheel and cut that off, and then what I'll do is I'll pocket that to whatever shape and put a similar shape. And then I have a few of these carbide rods I'll be able to take and solder these heads on to these carbide bars for my own purposes. So I was going to make a fixture anyhow for that, and so I thought, well, since I was going to make a fixture anyhow, I'll do this one, and I'll use it first on Keith's boring bar. And I can always make bushings that will go in these different holes so that I can accommodate different boring bars. And so what I have a thickness established here that we'll just get this in the range when this is in the top. This right here will be sitting in the bottom. And I got a little washer bolted on the bottom there that just keeps that from falling through. And that will hold it like so. And let me grab the tweezers a minute. Here we go. Yeah, the little piece of silver solder, it doesn't take a whole lot. So I got this little piece of silver solder right here. I'll just drop right in there. And then what I'll do is try to get that in there and get that lined up. And right now I can just let the weight of the carbide fall down in when that all melts, and it'll be good. Anyhow, I got this size right here in place so that this can move down wherever I need it. I can always make other blocks if I got taller bars or whatever I want to do. And I have a lot of room from here to here because I want the heat source more right on the cutting tip. If I would have made this a block, cut up close, well, with the torch, you know, trying to work real close to a thick block of metal, it's just going to be harder to have an even temperature. So I wanted to put another little support in between, so I have this set up, and I put gauge blocks in before I tighten it down, got a good feel. And then what I did, I could lock this in so that would, the gauge blocks felt real good in there, as what I have on there. And so that will just kind of help as the heat builds up on the end. I was worried that these may want to spread apart a little bit, and this will help out on that. Also, because this head right here is going to be bigger than this bar, I made this design so that I can remove this cap. It's right at the center line, and then I can pull the boring bar out that way. But what this does, it lines everything up. I have about 1,000 slip fit, 1,000 to 1,000, and it just let everything line up proper, and the weight of the carbide will come down, and hopefully everything will work good. If I focus on heating up the carbide and not putting as much heat on this because I don't want to draw that temper out of it. If I heat this up to a bright red, I'm gonna lose a lot of that temper. And so we're going to focus mainly on the carbide over there. And the other thing that I thought might help on this design was having some material thick here where we actually got the working part of it. Hopefully that will draw any excess heat away, and that way I'm hoping that I can maintain a good hardness on the piece after this is silver soldered. So we'll get started right here.